Hello guys, welcome back to MedZone African Motives, still on our Power Machines N6. And this is August 2022 exam, working on the internal combustion engines. So you're given 20 marks on this question number 5, everything on the internal combustion engines. So we're just gonna see the first part where we're given to explain the similarity between a turbine and an engine. That is, what do we consider to be a common thing between these two? So we know that it is the most important part between the two is that they both convert energy. All right, it's either it is into or it's from the fluid. All right, they both convert energy. That is, this can be heat energy, it can be chemical energy into the mechanical energy. That is the one that we refer to as the mechanical power. So we can simply say both convert energy in this case. So they both convert energy. And this energy that I'm talking about here, it can be heat or chemical. So this can be heat or it can be what? It can be chemical energy. That is, it can be converted from or in the fluid. All right. So it can be in or from the fluid. All right. So this energy is going to be converted into what? Into mechanical energy. So this is converted into the mechanical energy, which is the mechanical what? The mechanical power. That's the similarity that we have between these two. 3 marks for that, guys. Just to know this. Just to know this. All right. This is the most important question, and I'm going to take my time to explain this. There's a part that I need to talk about here about this indicator diagram concept. All right. So I'm just going to spend not much time. We need to calculate the indicated power in kilowatts from this information that we are given, whereby we are given that a 4-stroke single cylinder. So we are given 4 strokes there. So that is 4 strokes. And it's a single cylinder. That means E is equal to 1 for the number of cylinders. Internal combustion engine is a bore and stroke length, respectively. So the bore, that is the diameter in that case, all right? The bore, that is the diameter. So the diameter in millimeters, convert it to meters. That is divide by 1,000. That will be 0.146 in meters. The stroke length, 280 millimeters, converted to meters, divided by 1,000. That will be 0.28 in meters. So this is about the cylinder. All right. Then the speed. The engine runs at this speed of what? 475 revs per minute. Remember, the speed is affected by the what? The number of strokes. I talked about this. The speed that you are given, yes, it's 475 revs per minute. But because we are given that it is a 4-stroke cylinder, so meaning to say our N is going to be considered as revs per second over 2. You divide by 2. When it is a 4-stroke, a 2-stroke is going to be revs per second over 1. So how do we convert to revs per second? That is going to be 475 over 60. That is the revs per second. But we have to divide by 2. So we're just going to multiply by 2 in the denominator there. All right, just going to multiply by 2 like this. That's how our N is going to be used. And now they're giving us that the brake load, which is the force, which is our F brake, is given as what? 433 Newton at a torque arm. The torque arm, remember, the torque is given as what? The torque is given as the force times the radius. So the torque arm, that is the radius there that you're talking about. So they've got a radius of 0.45 in meters. If we divide by 1,000, that is going to be 0.45 in meters. Then they are now giving us about the indicator diagram, where I said I need to talk about that. It's only that I talked about this before the introduction. I needed to introduce this topic on the indicator diagram. But don't worry, I just hope I'm going to be able to explain in a way that you understand. So the indicator diagram is something of this nature, where it applies that you're going to have the area, the length that you're given on the indicator diagram, and the height that you're given on the indicator diagram, with the pressure, which is the indicated mean effective pressure. The indicated what? Mean effective pressure. of our internal combustion engine. So there we are given the area. I'm just going to take as it is. The use of units, you use the units as you are given. I'm going to talk about this according to our question. So we've got the indicator diagram there, where the area on the indicator diagram, this is not the area that is affecting the cylinder where we use pi d squared. No, this is the area on the indicator diagram. So it's given as 578 square millimeters, and also the length is given as 70 millimeters. So this is what we are given. And the spring, here's a rating, which is the spring rate in this case. On the indicator diagram, there's a spring rate. So there we are given our spring rate. Let me just explain about this indicator diagram separately. So we are given the spring rate in this case, which is the spring rate is simply, we are talking about what? The spring stiffness. So there we are given this as our spring rate, which is given as 81,500 Pascal per millimeter. All right. We are already given this per millimeter. Sometimes they might give you per centimeter. You have to convert your units to be per centimeters. I'm just gonna have an introduction so that you'll be able to understand that. So it follows that on this indicator diagram, this is what you need to understand. The indicated mean effective pressure, which is PM, is given from the formula that is the height times the stiffness, which is the spring stiffness. All right, let me talk about this. This is the formula that you need to know. The spring stiffness. So what are we talking about here? This is simply the height times the spring rate. The spring stiffness is simply what? The spring rate. Okay. So the question is, the spring rate here is given in Pascal per millimeter. We need the pressure in Pascal. And this rate here is given in what? The rate here, it is given in Pascal per millimeter. So it means this height here is supposed to be in what? In millimeters. Take note. Why? Take note. Millimeters times per millimeter. Pascal per millimeter. What does it mean? It's Pascal over a millimeter per millimeter over a millimeter. So it follows that the millimeter and the millimeter cancels. We are left with what? The Pascal. Guys, be careful. Why am I explaining this like this? It is because they might give you this way. You might be given this spring rate in pascals per centimeter. What does it mean? It means for us to have our indicated mean pressure, this one, in pascals or in kilopascals or whatever that you're going to convert, this height must be in centimeters so that the centimeter cancels with per centimeter, you are left with the Pascal. It cannot be millimeters where here it's per centimeter. No, it does not work like that. Per centimeter, height in centimeters. Per millimeter, height in millimeters. So you have to be careful. Here it was just an advantage that already we are given everything in millimeters, the area in millimeters, the length in millimeters. So definitely our height is going to be in millimeters. How do you find the height? Remember, this is a rectangle. So the area is simply the product of what? The area is simply the product of the length and the what? The height. Length times breadth. So we need the height. So it means the height is simply equivalent to what? You divide by the length, you divide by the length. So this is going to be the formula for the height. So the height is going to be area over the length. So it follows that on our formula here, in place of this height, we can even write as the area diagram over the length from the diagram, which is representing the height, times what? The spring rate. Times the spring rate. That's it. So we have the area, 578, like I said, square millimeters over the length, which is given as 70 millimeters. So it's going to cancel this and this cancels. We get millimeters. So it means our height is in millimeters. times the spring rate, which is the spring rate is Pascal per millimeter. It's Pascal per millimeter. So it cancels. You remain with what? With Pascal. So it means this is the exactly approach that you're supposed to have. So this is our indicated mean effective pressure. We are not asked about this, but you see, we are going to need it. We are going to need it. So this is the idea there. You take it from the area. How do you calculate the height? You take it from the area, length times height. You make the height the subject, that is divided by length. So this is going to give us the pressure, which is the indicated mean effective pressure in Pascal. All right? So that is the idea there. Let us just take our calculator. So my calculator is already fixed to 3 decimal places. So it means we are going to have our answer to 3 decimal places. That is over 70 like this, multiplied to 81500 like this, multiplied. All right, that is the only thing that we have, sorry. That is the only thing that we have. So this is going to be something like 672, 9, something like that, comma, 1. All right, that is going to be comma 143. All right, comma 143. That's 672, 945, comma 143. That is 143 in what? In Pascals. All right, so that means we can be able to convert this to kilopascals if you want, but let us just leave it like that. So this is our indicated mean effective pressure. That is the indicated mean effective pressure, which we can even write this way: P indicated mean, P indicated mean, like this. So just let's just leave it like that. All right. So that was the issue of what? Of our indicator diagram. You need to know this information separately. Don't throw away that calculation. It is needed. Don't throw it away. That's why you see this question, it has got 9 marks. It is because you're going to pass through these calculations. So the first question was to calculate the indicated power in kilowatts, which is 9 marks. So you wonder why 9 marks? And the formula for indicated power is given here. The indicated power is P indicated mean times length. All right? That is plan, from the plan. P indicated mean times length. You can use the plus concept. Plus over 6. It's up to you. All right? I'm going to explain this one that we have from our formula sheet. All right? So that you get used also to your formula sheet, guys. All right? So we are seeing that from our formula, it states that is 5.21. So this is the calculation actually of the what? Indicator diagram. This is our indicator diagram. So this was our indicator diagram calculations. So the indicated power, as we saw that from our formula sheet, it is given as the P indicated mean, that is the indicated mean pressure, times length. So this is from the plan. Some they use plus. So you check other textbooks, they use plus. All right, just gonna explain what you have from your formula sheet, guys. You understand me? So this is the indicated mean pressure, which is the one that we calculated here. This is the one that we calculated here. This is our indicated mean pressure. Remember, this is what we got from our indicator diagram. So what is the L representing? This is our stroke length. The area, this is not the area from our diagram. No, this is area from the cylinder, from the diameter. Our area is given as what? Pi d squared over 4. Then the N, which is the speed, I talked about this to say this N, that is the speed, is the one that is going to be affected by this now calculation of 472 over 60 times what? This calculation, because of we are given 4 strokes. So we have this N already. Then the E, which is the number of cylinders that we have, which is 1. So everything is there. We're just going to insert our values. Then we are done. That's it. We have got our indicated pressure, our indicated power. So in kilowatts, what does it mean for us to have our answer in kilowatts? It means we can convert this to kilowatts. This pressure that we are seeing here, we can convert it to kilowatts, or we can simply do it this way. Okay, let me just do it this way. I'm going to show you. So this is IP, which is our indicated power. So we're going to use the indicated mean pressure, our indicated mean pressure, which is our PM, the one that we calculated from our indicator diagram. We got 6, 7. So I'm not going to change anything. Let me just write as it is so that I do not confuse you guys. So this is 6, 7, 2, 9, 4, 5, 1, 4, 3 in Pascal. So if you use this in Pascal, it means your answer here is going to be in watts. We are going to obtain the answer in watts. So now we have the answer in kilowatts. What do? You multiply by 10 to the exponent of -3, of which you could have done it here. All right. So we are going to do it on our calculation here. All right. So like I said, the L is for the stroke length, which is 0.28 in meters, times the area, that is pi d squared. So it's going to be pi times d squared, the diameter, that is the bore, in this case, our diameter, which is 0.146 squared, everything over 4, times N. N is affected by the number of strokes. It's a 4-stroke. So I said for a 4-stroke, we are going to, all right, let me just write it here, guys. P indicated mean. Mean is equal to 6, 7, 2, 9, 4, 5, 1, 4, 3. Why are we even using like this? No problem. Just gonna, no problem, guys. Let me just remove this. All right. So this is the N as it is from this. That is 475, everything over 60 times 2 times. This is E, which is the number of cylinders, which is 1. So this is already in revs per second. Remember, we are supposed to obtain the joule per second. Joule per second, that is the watts. So in obtain the kilowatts, which is kilojoules per second, that is where we multiply by what? By 10 to the exponent of -3. This one is for conversion to what? To kilowatts. To kilowatts. But if you are using this pressure in kilopascal, don't use this 10 to the power of -3. All right. Here it's because our pressure is not in kilowatts. It's just a normal pressure. That is why we have to multiply by what? By 10 to the power of -3. All right. So there we need our calculator. Just hope, guys, we are going to win. As we can see, we've got a lot of things there. So this is, if you check, this part is the one that we are already having here, which is this one. This is already the one that we are having on our presentation. Remember, it was 478 over 478 from 578 from this times 8150 of that pressure that we're given here. This is the one that we got here. So we're just going to have a continuation. Now we're going to multiply by 0.28. So that's times 0.28. 0.28 like this times this one. Let us just take it aside. That's going to have a fraction, which is pi. So we're going to have shift pi like this times 0.146 squared. All right, I need a squared there. All right, that's everything over 4 for the area. So this is for the area. Then we're going to multiply the part of N in revs per second, but affected by the number of strokes that we are given. So this is 475 over what? Over 60 times 2. Okay, we have already converted to revs per second, so there's no need for you to reuse that all over 60. No. All right. Sorry, I forgot to multiply. So this is what you're going to get in the first place. You're going to get this in watts. But in order for you to have your answer in kilowatts, that's where I said you have now to multiply by what? By 10 to the exponent of -3. So by 10 to the exponent of -3, we are going to have our answer in kilowatts. So that is our answer that we are going to obtain, which is 12,487. All right. So this is 12,487. That is our indicated power. So that is 12,487 in what? In kilowatts. So the answer is automatically in kilowatts. That is our indicated what? Our indicated power in kilowatts. So it depends with the formula that you use. If you are using the place formula over 60, know how to use it. If you are using this planned concept, P indicated mean, all right, that is the indicated mean pressure times length. Then you just have to know what each part represents there. All right, so that was the 9 marks for that because of how you had to calculate those or remember I erased those calculations. Remember all those calculations that we had. Then now they want us to calculate the brake power in kilowatts. The brake power. So we were given something about the brake, the F brake, this and that. All right. So I'm just going to remove this part. Remember, guys, we have this. I'm just going to write the answer so that I utilize this one. We're even done. We are not going to need this anymore. So let's just remove this part. All right. Sorry for this, guys. Sorry for this. I want you to understand me. All right. Remember, we calculated the indicated power. We got 12,487 kilowatts. If let's say, but in this case now, they're asking us to calculate this because in most cases, they might give you mechanical efficiency. If you are given the mechanical efficiency and you have to calculate the brake power and you've got this indicated power, you can use mechanical efficiency. I talked about that. But in this case, we are not given the mechanical. We have to calculate it later on. So we are going to use the normal formula for the brake power. And what is the normal formula for the brake power? Let us get to our formula sheet. Remember, there are two formulas there that I talked about. The one for 2 pi times 10 over 60, where T is the torque that you use from the force times the radius. Or we can use F brake mean, but we are not given the brake mean pressure. All right, the brake mean pressure we do not have. We have only the indicated mean pressure, but the brake we do not have. So this formula is totally out. So we're going to focus on this formula. Let us write this formula, that is 2 pi n. So we saw that the formula for the brake power is given by 2 pi times nt or tn. All right, we're gonna use nt or tn. It's up to you guys, over 60. All right. So this is it. We were given the brake force and also the radius. That means we can calculate the torque also from the formula there. We saw the formula for the torque is given. That torque is given as force times what? Radius. So the torque is the force that you're given, which is the F brake. This is the F brake, which is given as 433 times the radius. We have the radius in this case, which is 0.45 in meters. Your radius is supposed to be in what? In meters. So that is going to give us our torque in what? In Newton meters. So if you multiply properly, you're going to get something like 194,85. That is measured in what? In Newton meters. So having this torque that we have obtained, it can help us now to calculate our brake power, which is going to be 2 pi times the torque that we are given. That is 194,85 times the speed. This n over 60 is to give us the speed in revs per minute. So we are taking the speed as it is. We are not using any number of strokes there. No, we are taking the speed as it is, 475. This is our speed as it is in revs per minute. So that's 475 there. You take it as it is. That's 475, everything over what? Over 60 to convert to the revs per second. So this is going to give us the brake power in watts, direct in watts. And that was going to give us 9692,206. Also confirm with your calculator, guys, in terms of your calculations, because we might just make a simple error in our calculations. So to convert to kilowatts, just divide by 1,000 or just multiply by 10 to the exponent of -3. Your answer will be automatically in kilowatts. So it is going to be 9,692206. So to 3 decimal places, it's going to be 692. Automatically in what? In kilowatts. That's your brake power. That's your brake power. All right? Just like that. So now as you consider, like I said, sometimes they'll ask you to calculate the to calculate the brake power given mechanical efficiency. But now they want you to calculate the mechanical efficiency at the end. We know, guys, mechanical efficiency is as a result of the two, the brake power and the indicated power. I talked about this. All these formulas are a repetition. Also, you have it. Let's go back to our formula sheet. If you're having any confusion, your formula sheet is given. The mechanical efficiency is given as what? The brake power over the indicated power. So that's it. So that means 5.23 our mechanical efficiency is going to be the brake power over the indicated power. So as a percentage, you multiply by what? By 100%. We calculated that the brake power as it is, that is 9,692 over the indicated power in the same units, which is the kilowatts, which is 12,487. Both are in kilowatts. So that means kilowatt and kilowatt will cancel. So this will give us our mechanical efficiency, which is given as what? That was going to be 77,6167, something like that, which is 617 to 3 decimal places as a percentage. Just like that, 20 marks. So you see, you need to know your indicator diagram. The whole information was based on the indicator diagram. If you do not know that idea, or if you just skip it and say, no, this information is not important, you see, it's very, very important. The indicator diagram can be the basis. It can be the basis of what? Your question, like this one. It was the basis of our question because everything lies on that. So more questions to come from Mason African Motives till we meet again.